Hey everybody, welcome to Hilltop Machine Works. Well, hey everybody, it's Tom here. As you can see, I am in front of the shaper. So we have just been hanging out, getting acquainted, and probably going to take her out to Starbucks here in a little bit, and I'll get me like a mochaccino, and she'll get a ISO 32 whey oil, and then we'll probably go out for dinner and a movie, and come back and probably make some chips. Anyways, just kidding. Hey, so anyways, going to do a little project with the shaper, and I was going to educate you guys a little bit on the shaper, let you know what I learned, which I kind of found out interesting. Is that once I started doing some research, that there is a ton of information on the Atlas lathes. I mean, you can go to forums, and then under subforums, I mean, they have their own Atlas lathe talk group, and they have, log your serial numbers, and I mean, they break it down and how to get, this, that repaired, and this is what you need to do for this. This is a common problem. I mean, ton of information on the Atlas lathes. But when I looked at for the Atlas shaper, there really wasn't that much. I was kind of surprised. But what I did find out is that the introduction of the Atlas shaper from the Atlas Press Company was in 1938, and that's what it looked like when it came out. As you can see, the table is three-sided. The bottom is open. So doing a little research, trying to find out about mine, that if we go and look at mine here, I'll show you here in a second, but my table actually has four sides. It has a bottom. So looking in the 1939 catalog, that's when I found, that's when they introduced the four-sided table. Looking in the 1940 catalog, it also has the same four-sided table. And then in 1941, they go to the latest version, which they continued to make until at least the 50s. I haven't found out when they ceased production yet. And that's when they added the foot at the bottom of the table, and they also added way wipers for the ram and for the table itself. So basically you have three versions. You have the 1938 1 year, then you have the 39 and 40, and then you have the 41 and on up till they cease production. So looking at mine, we have figured out mine is a 1939 model from the serial number. It's serial number 1202, and that for those 2 years in that transition, they made about 1,750. 1939 and 1940. So kind of interesting. Let me move the camera around and show you a couple things here. So hopefully you can see that pretty well. So this is what I'm talking about with the bottom. See, it's a four-sided box. It's not open like the 1938 one when that came out. But you could get this shaper in several different configurations. So what I found interesting is you can buy the shaper complete with the guards minus the motor and the stand for one price. You could buy the shaper no motor, no guards, no stand, basically just the shaper itself, and then you can buy it with a motor, and you can buy it with the stand. So you can kind of order it from cheap to deluxe, however you wanted. And looking at mine, it appears that the owner ordered it with the guards, ordered it with the legs, but he ordered it without the motor, because it is not an Atlas motor. It's actually a Dunlop motor. And from what I've been able to research, it's not like he ordered an Atlas motor and then it died and he replaced it with a Dunlop. I would venture to say that because the Dunlop motor was produced up till 1943, So it's probably the original motor that the original purchaser put on the Shaper back in 1939, and to save a couple bucks he went to the Sears and Roebuck company and got it instead of buying it through Atlas. So let me show you. Well, I'm trying to get you in there. I don't know if you can see down there in the bottom, but it says Sears, Roebuck and Company, and then there is the Dunlop name, and this is a 3rd horsepower motor. So that's probably what the owner did. Now the previous owner, during his several moves, let me give you some light. This bracket there got broke, and then also moving over here, this guard got damaged in the several moves that the previous owner was involved with, because he was in the military and he got moved around a whole bunch. So I got lucky, and here's the original bracket. As you can see, it got broke right there. It is cast, of course, so made it difficult to repair. It's such a short little run there that I was trying to figure out what would be a good way to repair this thing. If it's cast steel, it wouldn't be that big of a deal. We could buzz that thing with a MIG, but since it's cast iron, you know, could maybe TIG it with some silicone bronze, and then I'll just still have to clean the bottom up and get it flat. So I was kind of debating whether even to mess with it. So I thought about machining one, and instead of machining it, I decided, well, let's see if we can get lucky and look on eBay. And sure enough, I scored. So I got a replacement bracket. This bracket also fits on the Atlas lathes and holds the guard cover over the belts on the lathe itself, so they're interchangeable, which was smart by Atlas, so that way I didn't have to make 2 different brackets for 2 different applications. You know, it crossed over. So these brackets are, I wouldn't say plentiful, but at least you can still find them. You know, it'd be difficult to find them if, you know, this was a one-off item. So I've got that repaired. Next is to fix the guard here. This is steel and this is cast aluminum, and they have bonded together and have become one. I've tried everything to get it off, but it just doesn't want to give up and slide off. So I think what I'm going to do on this repair here, clean it out a little bit, and I picked up some of this metal epoxy, and I figured give that a try before it breaks off totally, and then I think we'll be good to go on that. So that's what I'm going to do here. I'll probably do that off camera, no big deal on that. But the main fix that we're going to have to deal with is, let me move some light over here so you can see better. Hold on. Alright, that's a little better, now you can see. So go figure, the original switch decides to give up the ghost once I get this thing home. It worked like twice and then quit working. You know, traced it all out, put my meter on it, and sure enough, you know, the switch is not working. The switch is in some Romex, which is run inside the cavity of the shaper itself, and to pull all that out, that means I got, you know, pull out all the guts and all the internals. Really don't want to do that. And that switch is still subject to you know, oil and grease and everything getting thrown up on it. So I'm kind of surprised it made the 80+ years or so, you know, this far. So just to put a standard switch in, I mean, it could do it, but I figured I'm just going to leave it as is, and we'll add an external switch down here. So I got on eBay and started looking, and I was trying to find some cool switches, and I couldn't find anything. So you know, I just ended up getting this simple on-off switch with a housing, It's plastic, and it was like $6.95 or something. So I picked this up, and it'll work. But then I just started thinking it just doesn't look right, you know. I mean, this is a nice vintage piece of machinery, and then I got this, you know, 21st century piece of plastic. You know, let's go to plan B. So I got on the internet and searching eBay again and doing vintage switches and machinery switches, antique switches, on off, and finally found some, and I found this one. Cool, new old stock, vintage. I was like, sweet, this will work out perfect. It'll look, you know, like it belongs there. So unfortunately it was a auction. I had to buy it now. So I had to wait like 5 days to win. And of course, you know, like an hour before the auction getting ready to end, somebody started bidding on it. Ran it up to about 18 bucks, but I still won it in the end, so it cost me like $19 in the shipping, so I got about $30 in this thing. But I was like, okay, that's not bad. Well, if you notice, you push it in, it doesn't stay. So it's kind of weird what's going on in here. I'm not really sure. It must be for a special application. If you look in there, there's some contacts, so when you press this down, you know, it completes the circuit, but yet you lift your finger up and the circuit disconnects. I thought, okay, well, maybe it needs power, maybe it's kind of like a relay, and then once it's got power and it magnetizes and it stays closed when you press it. But I put power to it, that's not the case. So I got a $30 elephant here, so this won't work. So I was like, okay, now what am I going to do? I've got about, what, $30 in that one, another $6-7 bucks in the other switch. This is starting to get expensive. And then I ran across this cool little doodad. Hopefully you guys can see that. This retro antique looking on-off faceplate. It's a reproduction, nickel finish from a seller, I don't know, out west, Vintage Lamps or something. It was like $3. I was like, okay, cool. What we'll do is we'll just go ahead and build one. So I ordered me some toggle switches because it was cheaper to buy 5 for 10 bucks than to buy 1 for 6. And we're going to make us an external switch. Picked up some Delrin. So what we're going to do is, the rest of this video, this is going to be the project. What we're going to do is we're going to make this a housing. What we'll do is you know, mill it out, drill a couple holes, get her down. I might probably turn some of this on the lathe, and we'll make a cool housing. We'll put a switch in it, we'll wire it up, and this baby will be good to go. So let me get this thing set up, and let's get to machining. Alright, set up over here at the mill. Found my X and Y, moved in, so I'm in the center of the block. So hopefully you guys can see this. This is the side of the block, but what I'm going to do is drill that hole. That's going to be 15-30 seconds. That's going to be where the neck of the toggle switch is going to go through. And then I think what we're going to do after that is take it over to the lathe, and I'm going to hopefully pinch it down in a mandrel. That's why I want to drill the hole first, and then we'll take off this material and this material, and then also that will leave these corners here, radiuses on them, and we'll radius these corners here so they'll be strong. And once we get that done, then we'll bring it back over to the mill out this pocket here. This is where the body of the switch will be, and then drill 2 through holes and countersink them, and that'll be the 2 mounting points. So I'll give you an idea of the method to the madness. Let's get a hole punched. easy breezy, onto the lathe. Well, as luck would have it, I don't have any mandrels that fits this 15/32 hole. So, yeah, we're gonna have to make one. So I got a 1/2-inch bolt, and what we're gonna do is we'll turn this down to 7/16, so that way it'll fit the hole. Or I'll turn this down to fit the hole, turn this part down to 7/16 to thread it. And then we'll have to cut a thread here so I can have a shoulder bolt so we can wedge this, nut this, and then it should be good to go. So let me whip this out real quick. Alrighty, just starting to turn her down here. Let me see what we got to start with. 60 in, okay. Alright, sweet. There we go. Now let me turn this down and we'll thread this to 7/16. Just cut and thread. This is the 7/16/14. Just going slow. This is a grade 8 bolt, so this is gonna fight me the whole way. Didn't have a grade 5. Be a little bit softer. But you get the idea. Alrighty, the mandrel is done, and what I decided to do is go ahead and cut out these corners here on the dual bandsaw. That way it will save the chip mess. Will be a little bit less on the lathe and throwing this Delrin everywhere. So, and all I have to do then is basically come down there and trim her up. So let's fire this baby up, and we turn the power on. There we go. Hopefully you guys can see that pretty good. See what I mean is stringiness, what it's going to be like on the lathe. Can't see, get out of the way. Alright, both sides are cut. Didn't bore you with cutting the other one. Got her chucked up in the lathe, and let's give it a try. See how she's going to cut. Hopefully it'll cooperate. Not going to spin it very fast so you get an idea of what we got going on here. See if she'll like us or not. Idea of how she's going to run. Let's see how she's cutting, what she's cutting. Alright, she's getting there and there. That don't look too bad. I'm going to get my zero while I'm here right now, I guess. Hopefully you can see this. Just starting around this side, and then these are coming in pretty good. So we'll continue on a little bit on camera. Only taking about 20 thou, 40 thou total. I'm just not sure how much of a bite I got on the mandrel with those nuts. The Delrin doesn't want to spin on me. And it's no rush. It's a nice sunny day in the shop, so I'll just peck along. Anyways, you get the idea, guys. As you can see, she's starting to form. Obviously this side is a little bit longer than this side, but let me do a little more work on it so you're not bored, and I'll bring you back when we're getting close and we're getting a good shape to her. Alright, hope you can see that. Almost cleaned up. I got just a smidgen right there, so we'll go in about another 10, but otherwise looking good. So I'll bring you along for this last pass. You can see this is the mess that I was talking about with all the little chips. That's why I cut a bunch of it off at the bandsaw so it wouldn't be so bad. Almost there, and it's coming in. Should be it. Let me pull her out. There you go, cleaned up good, looks good, we got a nice radius. Sweet, now all we need to do is clean these feet up right here, and then we'll be moving over to the mill. Alright, I just finished the last pass. You can see the feet came out nice. So, fortunately she's sticking out so wide I have to do a lot of rearranging to try to get these corners ready. So what I think I'm going to do is just hit this on the belt sander. Nothing special, but there she is, looking good. So, let's get her out of here and get her over to the mill. Of course. Let's try this again with it plugged in. What do you think? That'd work better. Let's take these corners down. See that? Looks pretty good. And And now let's mill this pocket out, and then we've got to drill and countersink 2 holes right here, and we'll have us a switch housing. Alright, got you set up over here at the mill. Well, I got the drill chuck in. I figure I'll go ahead and punch the 2 holes for the screws, and then once we take this chuck out, then we'll put the collet in and we'll mill that center section. So let's punch a couple holes. Delrin. And all I'm doing is just coming in here with a piece of paper, find out where she's at. Alrighty. 170. Two. Two coming up and 0 off the table, and we should be right where we need to be again. Perfect, sweet. A couple holes. Let me get the drill chuck out, get the collet in. We got a 5/8. We'll clean out a cavity. Alright, getting my 0 set for my depth. We got to go down 1 inch, 360 thou, and it's a 5/8 end mill, so we're going to go basically 1 inch, 0.062 each way. So let's do this thing. Alright, let's try that again, because after I read those numbers to you, something didn't compute, and I'm glad I did, because one didn't look right. So actually we've got to move over 0.438 each side, take into account the diameter of the end mill, so we get a total depth of 1.5 inches basically on our X travel. Stringy stuff, that's for sure. I'll go down about 1/2 inch and we'll move back each way when we do it that way. Alright, that's half there. Lock the table. Let's take a peek so you see what she looks like. Can't see anything with all these nasty chips. Alright, slot looks good actually. Cool. You guys see that pretty good? Let me zoom in a little bit. There you go. Alright, let's plunge then. Back to 0. And down another 1/2 inch. Using a 2-flute hand mill, by the way. I'm hoping to evacuate these chips better, but that's what you get with Delrin. Alright, we're there. Reload. Finish up and I'll bring you back when I'm done. Alrighty guys, hopefully you can see that. Trying to get a little light in there. There's the pocket. So she came out good. Old switch fits in there nicely. Came out really nice, so don't hardly have any movement. And this is going to go on like that, and then of course we'll put the nut on there. The only thing is the holes are a little bit closer than I like, so I think I'm going to have to drill down here just a little bit, and then we'll countersink this thing. And then obviously I need to notch, I'm getting the light a little bit, I guess I'll turn you guys this way, then notch this little area right here for the wires to come in. So couple small little operations and this thing will be done. Alrighty, just used a 5/16 drill and did a couple little quick countersinks. So now she looks good. Get you in frame and back you up there. So there we go. Fits nicely. Sweet. Alright, just milling the slot for the cord. I think we got us a winner there, guys. Cool. Alright, let's get her out and cleaned up and deburred. Well, there you go. I think she came out good. And got her wired up. A little knot in the pocket so she won't pull. Little 16 gauge. Should be fine. So what do you say we go over and get this thing mounted and wired up? Well, give you a look. Getting ready to wrap her up here. I'm gonna close this cover. I got her all wired up. And give this baby a test run. What do you think? Screw start. Plug her in. And bring you guys back so we can see better. See what we got going on here. So there's the switch mounted. I think it looks good. Here, power. That's a good sign. No sparks, right? And action. Sweet. So I like that. Let me turn it down so I can see a little bit. I think this looks a lot better than if I would have gone with that. You know, this would work, but probably just you know, it doesn't fit the retro look. So I'm glad we went with this idea here. And let me bring you around. Also figured I'd give you an update on the epoxy. That metal epoxy worked great. I'm glad I went with that idea. As you can see, she is nice and strong, and doesn't look bad either. Kind of gives it that used look. So all in all, very pleased. So hey, I think this project is wrapped up. We have us a power switch, so the shaper is now working. All the little knickknacks are fixed on it. All I gotta do is kind of do a little more cleaning and watch a couple more YouTube videos to learn how to use this thing. I kind of got an idea of how I should adjust the clapper box and this, that, and the other, and speeds and whatnot. So like I said, the next video is going to be, we're going to be cutting some chips on this baby. It's exciting. I can't wait. So hey, thanks for following along. I appreciate you guys out there. If you hadn't subscribed, hit that subscribe button. And if you're new to the channel, hey, I appreciate you joining. If you get a chance, check out all the other earlier videos. I got about 70 videos posted. Some of the neat projects were, so we built a weather vane and did some machine skates. Also built those cool legs for the arbor press. So go back and check out some of the earlier videos. I think you'll like them also. And until next time, we'll see you guys.